Hello, everyone, and welcome to our webinar, Create Embeddings on Real-Time Data with OpenAI and SingleStore Free Tier. My name is Matt Brown, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you're currently in a listen-only mode. You can use the Q&A in the lower section of your Zoom console throughout the session. If this is your first time joining a SingleStore webinar, heads up that we present regular webinars demoing data and AI use cases and new technologies. So if you click to the next slide, you will see that on Monday, we are going to be presenting using ANN, approximate nearest neighbors, for vector search at speed and scale. If you're like me, you have probably seen dozens of new AI applications coming online lately that are incredible. They're near magical, but they often have a laggy experience. So come join us on Monday to learn how speed at scale can be achieved using SingleStore's new features. If this is interesting to you, you can RSVP at the link. Click back one slide to see what I'm talking about. I'll put this link in the chat as well. But you can also take a photo or a screenshot of that QR code right now. And again, I'll put this tiny URL link in the chat in just a few minutes. I hope to see you there on Monday. Getting back to today's topic, we have fantastic technical experts who are part of this Zoom. They have a good grasp of the technologies and tools that are involved, ready to answer your questions along the way. So feel free to use that Q&A throughout the session. We'll also try to carve out some time at the end for live Q&A with our panelists. And we'd love for you to try today's technology. So if you click to the next slide, you'll see that we are offering a chance to win brand new AirPods Pros. It's the latest and greatest offering from Apple, new version. All you need to do is click that link that's on your screen. That's the tiny URL, real-time embeddings raffle. I'll put that link in the chat in a minute as well. That QR code will take you to the same place. Very simple to participate, just log in. You may know that SingleStore has had a free trial offer for a while now, but just in the past few days, we've also announced a free shared tier, which our speakers will be talking about a little bit today. Stay tuned for that. So the raffle process is very simple. Just visit that link, sign in. You can sign up for a new account or sign into an existing account, and you will be registered. And I'll announce that AirPods winner at the end of the session. So let me introduce our guests for today. Pranav Arora is a product manager at SingleStore, focusing on AI and developer experience. Previously worked at Microsoft. He's been hard at work at SingleStore for the past year and a half, working on many things, including our new free shared tier and embeddings job service that you'll see today. And then Yaroslav is a growth engineer at SingleStore, specializing in full stack AI web solutions. You might recognize him from his past contributions to the SingleStore Elegance SDK or the SingleStore ChatGPT plugin. Very exciting stuff. Welcome, Pranav and Yaroslav. Welcome to our audience as well. Pranav, I believe you have the floor first.
Yeah, thanks, Matt. Thanks for the great introduction, as always. Let's get started with what we're here for today. And our goal is to build a real-time RAG application. And the reason why real-time data is really important in this scenario is it provides the latest and greatest context to your LLMs. My scenario is very simple. I have a bunch of data in a bunch of different sources that it's constantly being updated. It's from GitHub, it's from Twitter. I have a MySQL source, a Snowflake source, and I want to be able to use all of that data as context to my LLMs downstream. A lot of these sources are constantly being updated in real time, and I want to be able to account for these changes to my LLM context. So my first step here is, how can I bring all of this data into SingleStore and enrich it with the embeddings so that it can be used downstream? We're going to do this entirely on SingleStore, and this is going to constantly look for data in these sources, add embeddings to them, and then insert them into SingleStore. All of this will be done with our notebooks and recently launched job service. Notebooks is a simple SQL and Python-based collaborative environment, and job service brings life to those notebooks where you can schedule these runs to happen on a time-based schedule based on your liking. With all of this, I can then connect my downstream app. Here we're using Vercel, a JavaScript app that does the hybrid search, that does the analytical queries, that does the point reads and writes. And I can connect that to that SingleStore database. All you really need for your modern day Gen AI applications is a single store database, because we power, vector search. We have SQL for your transactions, and we're really good at handling large queries and analytics. And these are often the three ingredients we're seeing, almost every enterprise using a single store for Gen AI, combining. And the great part of this is it's all a single database. And with our latest and greatest, innovations in notebooks and job service, we're making it really, really easy to do real-time RAG by piping in data from a bunch of different sources with embeddings associated. So the first thing I want to talk about is, why we address this problem, and how do people actually bring real-time data to their AI applications? It often looks like the diagram on the right. You have your core database, but all of your work streams live in separate compute instances and are all sort of all over the place. Like you have your Python notebooks where you prototype, then you sort of run ETL jobs separately using some kind of AWS or serverless service. Hosting and bringing in ML models is, again, a separate service, a separate compute instance. If you want to do your Python UDS, which are your user-defined functions, that also lives elsewhere. And with all of this, developers like you, we end up spending so much time on deploying our compute, on expensive jobs to move data around to various compute instances. And what gets compromised is security. Each time we move this data between sources and get it ready for applications, we're spending a lot of money, we're losing security, and the data loses its real timeness. As soon as data is created, it's not accessible for vector search downstream. And as a result, your LLMs lack the latest and greatest context. We're solving this with our compute service. Compute service brings GPUs, very cool memory optimized instances right next to your SingleStore database. It's available on demand. And as a result, it's very secure being co-located with your database. So in the middle, you have your SingleStore database. We are a SQL database that does vector search, that does analytics, that does transactions. And along the database, we now have this compute service where you can run your notebooks. And from your notebooks, you can schedule these jobs. You can schedule these notebooks as jobs that ensures your data is coming in with the right ETL process and has embeddings to it downstream. And this is just the start for us. With this compute service, we're going to be bringing services for you to host and bring in your own open source models, for you to create Python UDFs, for you to speed up vector index builds with our GPUs. So that's the webinar coming next Monday. And for you to build sort of data and dashboard apps right on SingleStore. This completes our journey as a data platform. And as a developer, all you need is a SingleStore database and the tools we have alongside SingleStore and a compute service, whether that's notebooks and job service, to ensure that your LLMs have the real-time context. And that's really important. We're calling this paradigm real-time RAG. This is going to be, in our view, the way 2024 gets shaped by, which is as soon as data is created, how can we pass it to the LLM and use it and the LLM uses it for context. So, this is the workflow I've been covering quite a bit. I spoke about quite a bit. We have notebooks. From there, you can schedule the notebooks, and you can even attach GPUs right from SingleStore. You don't have to configure a VPC, set up an EC2 instance, get the image ready there. All of this lives in SingleStore now. And some of the use cases we're really excited for, one of them is the real-time embeddings. This is what we're covering today. So as soon as data is created with streaming or batch data, real-time embeddings are created with it and stored in SingleStore. Our customers are using this today and have replaced Lambda plus SageMaker plus an ECR instance plus EventBridge. So this is really, really cool. Very easy to go, and I'll walk you through this later. People are creating dashboards directly on SingleStore with our notebooks. That's replacing Google Colab and Metabase. And people are also doing ETL jobs, which is, again, replacing that EC2 instance they need for compute, Airflow for a cron job, and EventBridge to orchestrate it. We can guarantee you lower cost, full data security and governance, and real-time performance. And this is the bucket we're going to cover today. This is the bucket we're very, very excited about at SingleStore. So let's go back to this demo architecture I showed you. My scenario is really, really simple. There is a massive explosion on the number of LLMs out there, and I should know which LLM I should be using for my use case. I want to build a recommendation engine that can account for all of this real-time data on what people are saying about LLMs, on how customers are using it, on what people on GitHub and Reddit and Twitter are talking about it. Uh, and I want to be able to account for all of these things about LLMs to give me a recommendation on what I should be using for my use case. The requirements are simple. I want to configure this app entirely within SingleStore, using a SingleStore database and using our compute service. So this is the diagram I showed earlier, which is our compute service with notebooks and job service, bringing in these data, real-time data from a bunch of sources, adding embeddings to it, and then storing it in SingleStore. And then I want to be able to build this app with Vercel. I love Vercel. And we have a great connector with Vercel now, and a great integration for you to do a one-click integration. And you don't have to configure your complex database strings and stuff like that. That integration is really neat and simple. The best part of this is all of this is now running on our free share tier. And this is really, really important because now you have access to these tools for free for good. There's no time limit on your trial. We give you a 1 GB SingleStore database that you can use for your prototype apps, for you to build these kind of scenarios, and that's yours to keep. You can build up to 10 tables with it. It comes with vector search, our latest and greatest vector index as well. You can use pipelines to bring in data. You can use our compute service with jobs and notebooks. We are really on a mission to be the developer data platform for the Gen AI era, and our free share tier is our marquee feature for that. It's a free SingleStore deployment for good on the cloud, and I'm very excited for you to try it. Just log into our portal, singlestore.com/cloud trial, and you'll be able to create a starter workspace, which is a free share tier instance, and that's yours to keep. So excited to see what you all build with it. And that's like I covered this in the slide. It's a 1 GB compressed storage, so you can even get up to 4 or 5 GB of storage in this. And that's very generous. Mongo gives you about 512 MB. So this is, just to put into perspective, it's a very generous offering. You get a lot of, the core values and DNA of SingleStore, which is hybrid search, real-time analytics, ability to scale seamlessly. You get all the great connectors with our ecosystem, with notebooks. And this is in public preview today. So like I said, go ahead, give us a try and give us feedback. Cool. Now, the way I'm going to be running this this session and this sort of the meat of it is there is a notebook available on Spaces. So if you go to singlestore.com/spaces and you go to real-time recommendation engine, you'll be able to create and follow along this tutorial. And I'll show you this here. Oops, sorry, that's not what I'm trying to show you. Okay. This is the Spaces notebook. I hope everyone can see this. This is the Spaces notebook, and if you click try now, it'll take you in Portal and follow these steps. And while you're at it, like Spaces has a bunch of other content that we publish and our community publishes on these topics, and you can easily follow along and follow our demo architecture. You can run code and SQL and Python directly from it. And once you click try now, you get eligible for our AirPods, and you'll be taken to this kind of screen in our portal where you'll see our notebook being rendered here. You'll see our architecture we're talking about, and you'll be able to follow along with our steps. The first step I want to talk about is creating our starter workspace. That's our free shared tier instance on the cloud. What I was showing you about, it's really easy to get started. You can create one on onboarding, and you can also create one with the plus group button here on the side. When you create a free, sorry, I haven't refreshed this, but when you create that new group, you'll see this screen where you can see your starter and your standard workspace. And your starter workspace, you can give it a name. And as soon as you click create, it's live. And that's the beauty of this this workspace. There's no complex deployment times that you might experience with other databases. This is your connection string. You can go build with it with your SQL editor, your Kai shell, and your notebook. Really, really easy to get started. And our developer team has done a lot to make that happen. So once you deploy your starter workspace, navigate back to your notebooks. And this is where you'll see your LLM recommender notebook in Portal. And you can just follow along these steps where here our first step is to bring in all the libraries. Like we said, the goal is to aggregate data from a bunch of sources. There's some great Python libraries that we can use for this. We're using OpenAI. We're using some of the APIs from Reddit and GitHub downstream as well. Here we just set some common app variables. We pointed to the right stuff. We set the model limits. Feel free to tinker with these, but be careful because this will, it's made to work at the scale that works with our free shared tier instance in our notebook. So it may not work if you tinker around with these too much. Add your open API keys. That's where you create your embeddings. And from Hugging Face is where we extract all this data on all the LLMs out there. Hugging Face is really incredible for that. There is a Hugging Face leaderboard spaces repo there with over 1,000 different LLMs and their different scoring metrics, what community members are using for which ones. So we want that to be our sort of single source of truth at the start. And that's how we sort of ingest all the data from Hugging Face. The next step is also setting data from Twitter and GitHub. Think of these as, our developer community, you, me, we always, are seeing and hearing people talk about these different LLMs online on different sources. And we want to be able to capsulate and use all of this data in our recommendations downstream. So we want to be able to capture what the community is talking about these LLMs on Twitter, be able to extract the sentiment for them by creating embeddings and storing that into SingleStore. Same with GitHub. We want to see how developers are using LLMs in their GitHub repos. What are the different READMEs in those GitHub repos where these LLMs are being used in reference, and create embeddings for that, store that in SingleStore, and have that be part of our recommendations. We can design our table schemas as well right within our notebooks, and this is again really easy. It's the single developer pane you need. And we are a SQL database. You'll have to create a table, but being a relational store, we have a lot of advantages than simple API-based approaches that some vector DBs might have. You can power your entire app with SingleStore. You can't do that with a lot of the vector databases. And that's because alongside storing your embeddings, which you can see here in this field I'm highlighting in the bottom, you can store all the other data that you need to power your app. You can store, this relational and structured data on things that you might be serving downstream. And all of this lives in the same table. I call this embeddings as a column, and I think it's the easiest way to associate and enrich your search with structured data, with embeddings, and have the richest context be passed to the downstream LLM. We do the same thing for a bunch of our different tables. So we create a table for our models, for Reddit, for Twitter, for GitHub, and it's the same schema where we're ingesting all of this data, which is the name, the description, and we're storing embeddings as a column in this database. So that's the first step we're doing. The next step we can do is bring in data from a bunch of sources. And when we bring in these data from the sources I was describing, I want to ensure that embeddings are created with it at the same time. And we do this with our create embedding function. So essentially, as soon as we ingest data, we can call this function on each and every entry, and that'll create embeddings for it and store that in SingleStore. So these are some of the helper functions we have written out to help you with this process of ingesting a bunch of data, breaking it into smaller chunks, and creating embeddings for it and storing that smaller chunks with embeddings in SingleStore. The next step is loading data, and loading data is really, really easy with a bunch of the stuff we're going to be releasing going forward in our Pro Max release. We have CDCN capabilities from MySQL and Mongo. We'll be having Iceberg capabilities as well downstream. But here in this case, I want to just load in data very easily from a Python data frame into SingleStore database. And we have some great libraries here that you can follow as well. And this is very performant because we push this execution engine as close to the database as possible. So this is with our SQL Alchemy engine. You can see some of the insert statements we have here, and we can run these into and insert them into SingleStore. So this is how we bring in data from our Hugging Face leaderboard, from our GitHub on model usage, And you can follow along these steps from Twitter. And we do the same for MySQL and Snowflake as well. It's a similar process, very easy to bring in data from a bunch of sources. So great. Now what this notebook has done is populate these data, my database in SingleStore once. It's with, it's up to date with real time with data. As soon as I run this, it's coming in. And I can see this in my free tier database I just created. I can see the tables, and I can within each table see sample data, and I can see that, hey, I have all of my data in, which is I've got my ID, I've got which GitHub repo is using it, what's the name of the model, and I have an embeddings column. So this is when you know you're in good shape, where you have that embeddings column, and this is upon which we'll be doing that vector search to provide the right context to the LLM. So going back to our notebook, great. I've populated my tables once. All of these sources have brought in data into SingleStore, really easy in notebooks. You can follow along. All you need to do is just run the steps, bring in your own API keys. Now, how do I do this real timeness? I've been talking about that quite a bit. I want to ensure that as soon as people are talking about this, an LLM on Twitter and GitHub, we're extracting what people are saying, the sentiment of what they're saying, and encountering them in our and using them for our recommendations. And we can do that with our new scheduling feature. We call the SingleStore job service. You can select which notebook you want to schedule. You can select which database you want it to schedule on. So here I want to use it on my LLM recommender prod database. And I can choose to run this every hour. And that's it. That's how I ensure that this entire notebook with all the steps I showed you runs every hour. And when it runs every hour, it continues to bring in data, fresh data from all these sources, adds embeddings to them with our helper functions, and stores them in SingleStore. And that's it. And I think that's the ease of use we were very, particular about driving. And this helps, you don't need to configure your complex EC2 instance and have a separate cron job with an event bridge sort of serverless stuff. It replaces so many serverless functions that you would need to replicate this. All of this on a notebook with scheduling capabilities. So now I have the backend of my app set up, which is all of the data is being fed into SingleStore, and all of the data is being live, and all of the data is being kept up to date. How do I build my front end application? And with that, we have our amazing Vercel integration. I'm really excited about this. Here I have a Vercel project, which is this LLM recommender I'm talking about. And when you configure our integration with the marketplace, what you'll eventually see is your oops, sorry, not here. You'll see your environment variables be populated. And these are the environment variables from your free shared tier instance. So it's your workspace name, your host, your password, your database name, all that gets populated. And if I go back to my project, I can see, I can ensure that my front end has access to my backend. And that's really easy through Vercel and our integration. The final app looks like this. So it's a, we call this our LLM recommender. So if you want to do a dummy scenario, if I want to find which LLM should I use for writing a book on law, it should be able to, give me recommendations of which LLMs I should be using. And more importantly, it should be able to pull in data from my SingleStore instance and use the real-time data in providing these recommendations. So if I go here, I can see, why like I get this recommendation on this Mistral open source LLM and why it's a good fit for me. Here it's, it's an excellent choice for text synthesis. I get a semantic search score. There's a similarity score, number of likes and downloads based on the Hugging Face repo. I get all of these scores that are often used to benchmark LLMs, and I can get further details on this, which gives me a more up to date on how to use it. All of this is powered by a free SingleStore instance. And that's the beauty of SingleStore and why we were very excited about this for the Gen AI era. You can't do this with a specialty vector database, and all of the transactions, the analytics we're providing to users, as well as the vector search is all on a single database. Really easy to get started. Now I want to hand it over to Yaroslav. I will answer some questions in the chat, but I want to hand it over to Yaroslav to walk you through the front end of the application, how we built this UI, and how we built this with our Elegance SDK, which is a JavaScript SDK for you to really make vector search an easy sort of SDK through a familiar interface. So Yaroslav, on to you.
Thank you, Pranav. Now, guys, let me just tell you how we build this application. And just let me share my screen.
Did we lose Yaroslav?
Maybe so. I'm not seeing him. Maybe I'll ping him on Slack and see if we can get him back online. He might not even know.
Okay. I think he's back.
I'm so sorry, my macOS system was not able to share my screen. I'm sorry. So now, do you see my screen, guys? Just let me know.
Looks good. Yeah, maybe a little bit bigger in size.
Yeah, sure. Okay, so as mentioned before, we built this application using the Elegance SDK, Versa connector, and SingleStore free tier. To get started quick with Next.js application, you can use npx create SingleStore DB command to create a Next.js application with already installed Elegance SDK. To do it, you just need to run npx create SingleStore app template and specify the template what you want, which you want to use. It's Elegance Next or Elegance Express. Then here we have SingleStore Elegance SDK. This SDK allows you to operate with SingleStore database in any JavaScript environment. It can be like client-side environment or server-side environment, any JavaScript environment, Node.js, Next.js, Get.js, doesn't matter. To get started, you can just follow the links here, follow to the elegantsdk.com. And here you can find get started on documentation parts. Then we have Versa connector, which allows us quickly connect our SingleStore workspace to Next.js application, which deployed on Versa SDK. Then we have our LLM recommender. As mentioned before, this application is simple Next.js application without any server and Elegance SDK. Pranav already showed how it looks. And now let me just dive into code and show you how did we implement the algorithm to get recommendations on the front-end side. Here we have front-end folder, which is our Next.js application. And we can find services folder with Elegant Server Client. And here you can see when you use npx create SingleStore DB application, all of this setup is ready to use. Then we have API folder with models search API road. Here I imported Elegant Server Client and some ready-to-use functions like AI helper functions and controllers. Here we have post handler, which handles the user input, which is use case. So anything you write here, we get it in this API handler. Then we create prompt embedding using the Elegance SDK AI create embedding helper function. It creates OpenAI embedding, and and then we are ready to use it in our vector search. So here we have several tables. We have models, model readmes, Twitter posts, Reddit posts, and GitHub repositories. To get results from all these tables, I just used vector search function from the Elegance SDK, which executes which performs a vector search based on your prompt and table, which is collection. It finds the most similar results that are related to the user prompt. Once we get all these vector searches, we group them by models, by model name. So we have like some model name and all related data, like from posts and GitHub repositories. Then we count total similarity and average similarity to get average similarities that will be sorted by highest to lowest. And we had 5 results from this search. Then when we have ready to, when all models are ready, for each model, we get some data from our database, like another data from model, like test results or after name or model name, likes and downloads amount number. And for each model, we also create and we also use Elegance SDK create chat completion function to create chat completion using the OpenAI chat completion API for each found model. We are providing some context to this API, like here's the user use case, here's the LLM name, LLM description, and what people share on Twitter, on Reddit, and GitHub. Based on this data, OpenAI returns returns us chat completion, which describes why some model is relevant to the user use case. And once it's ready, we get search models, which is our result, and then we show them here on this page. So that's it. We have a lot of ready-to-use tools to build real-time AI application in fast way. We have npx command to get Next.js application with Elegance SDK. We have Elegance SDK, which has a lot of functions to operate with database, like find many, find one, create, and AI functions, helper functions. And also we have Versal connector, which is a great tool when we can seamlessly connect the SingleStore's workspace with Versal. Like here, if you go to the environment variables, we can see that all these variables are predefined by Versal connector. And here's the final app. So that's it. Thank you, guys.
Awesome. Thanks, Yaroslav. Pranav, anything else you want to cover today, or you think we're good to get into the audience Q&A portion of our show?
Yeah, I think what the way we wanted to structure this demo and how Yaroslav and I conducted it was, SingleStore and notebooks and job services, how you can ensure that your data is ready to be searched downstream. And we have great connectors with your front end of your application with Vercel and our Elegance SDK for you to query that data in a familiar API-based shape. So that's sort of the recipe we see a lot of the apps going forward in this real-time AI space. We're excited to get feedback from the community on how we can make it better.
Awesome. Thanks, Pranav. Just a reminder to our audience, you are welcome to participate in the Q&A. There's a button at the bottom of your screen. I know we've already answered dozens of questions digitally, and I see more coming in as we speak. So keep those coming. If there's anything that we don't get to, we will follow up with you via email. So I know, Pranav, one that I've seen occasionally in our Q&A here today and also in past webinars has to do with like chunking sizes and there's paid services and there's free services, but I wonder if you want to talk at all about just chunking and token size limit best practice.
Oh, I think we're losing you. We're losing you a bit, Matt. I think I got the question. Yeah, it's on chunking and best practices to do with chunking. We have some functions here in our notebook. We chunk data into smaller pieces and then create embeddings for this. Yeah, our stuff can provide more color on this. The way I like to think about this is it's not a science. I can't tell you a formula. It's a very use case dependent on the sources of your data. The way I like to approach chunking, and I think it's again, like I said, it's an art. It needs to ensure that each of the semantically relevant information is sort of kept in the same piece of information, and then anything that has opposing semantic relevance uh, is kept as a separate chunk. And the way, again, it depends on the input source. Like for Twitter, for example, it wouldn't be based on context size, but it would be based on, whether a tweet and a reply are treated differently, or whether two different tweets are treated differently. Same with, different sections in a book or in a GitHub repo. I think that's the most important thing. But yeah, I don't have a science formula on how to go about chunking. I don't think anybody will be able to explain that to you.
Yeah, agreed. I see some more questions. I know this one's near and dear to you, Pranav, so I'll pose it to you again. Is it possible to create Python files inside SingleStore workbooks, or is it always necessary to work in Jupyter notebooks?
For now, it's Jupyter Notebooks. We will add the way we've built our compute services, it's very easy for us to do stuff like adding Python files and running Python files within our compute service. So for now, Jupyter Notebooks will make it easy for you to go from Jupyter Notebook to Python file, or even just build with a Python file directly.
Good stuff.
I had one, sorry, Matt, if you don't mind, I'm just gonna tackle one question with Julian. And I think Julian asked earlier, why would you use SingleStore if it's not a real-time use case? And then my follow-up was that, it's the richest context to LLM. And I have sort of an enterprise lens on this as well, where customers want to have a single pane to query all of their data and get the relevant, and when I mean query, I mean semantic meaning, which is semantic search. I mean exact keyword meaning, which is full text search we support. Analytics, which is combining and aggregating a bunch of data, being able to get the outputs of all of these different query methods, and filtering with SQL as well is a big one, and passing all of this data that's as, I guess almost as robust as it gets about your enterprise, and passing that to the LLM. And the scenario there is reducing hallucinations. It's also ensuring that your LLM has all the relevant context about you. And this is the biggest, the most common pattern we're seeing at enterprise level amongst our PLG customers as well. And it's why a lot of them are choosing SingleStore as their vector store, and their knowledge hub is for the richness we can provide through a simple SQL-based interface.
Good call. I see here's a questions about where was your embedding done? It sounds like this person's having some trouble with OpenAI embeddings. I should point out we've done lots of webinars on Mistral, Llama. We're very agnostic in that, so I'm going to put that into the chat. I'll put some of the links to the other LLMs, but Pranav, I wonder if you or Yaroslav can talk a little bit about your process for embeddings.
Yeah, yeah. I'm not, I don't think I have a embedding model of choice. We used OpenAI here. Hugging Face is some great open source ones that you can use with sentence transformer that are really small and powerful. And as Matt said, we want to keep it as agnostic as possible. So bring your own embedding models and we'll support it. And we have also great integrations with Llama Index and LangChain as well. So like we're not tied to that OpenAI ecosystem at all.
Yeah,
Go ahead.
oh,
Go ahead, Yaroslav.
I can add that embeddings is on the developer side. You can use any embeddings library to create embeddings and insert them in the SingleStore database. So we are not limit you with what model you want to use to create embeddings. But it's very important to mention that you need to use the same model for on the server side, you have to create all the embeddings, like create all data for search, and the same model to convert user query or user prompt into embedding, because the length of embeddings on different embedding models are different. So these variables must match.
Good stuff. I'm seeing a lot of questions about just security and I've seen this a lot in our past webinars, just folks and companies that are worried about exposing their data. Even though OpenAI has released a lot of statements recently about not training on data and not sharing data, but I feel like there's still a lot of skepticism out there floating around, probably related to people trying to like hack the OpenAI and get access to data through various little tricks. So anyways, I'm going to put this into the chat as well. I answered a question, but we have done multiple webinars on fully private options, even getting your embeddings done locally on different LLMs. So I just put that into the chat. And yeah, I'll defer Pranav or Yaroslav. Anything you guys want to add to that, or you want to jump into the next question?
I'm good to go to the next question.
Okay, great. I see some questions about scale, and I know that scale is kind of like one of SingleStore's value propositions. So folks are talking about like what's the largest scale that you've seen in vector use cases, and I'm sure Eric Hansen might even give us a better answer. But Pranav, can you think of anything offhand in terms of demonstrating scale here?
Yeah, great timing. I actually ran this yesterday. We demoed 400 million vectors with our new ANN index. So that's the webinar on Monday. Our ANN index, 400 million vectors at 10,000 query per second. So I think that's 20 millisecond 20 millisecond response time. And that's, if we were to benchmark it, and this is something that we're working on right now, we are, almost at the upper end of the performance of, very expensive specialized vector databases. And we're a SQL engine. We're a full database that does all the other things alongside your vector search. So that's really incredible. And I saw another question on what vector DB are we using to solve to store embeddings? Is it ChromaDB? No, this is SingleStore. Like SingleStore does, we do have support for vectors, and we do store vectors as a column in our SQL database. And we do have this ANN index, which is a retrieval tool for massive scale. So about anything above 10 million vectors was I think how I would see it to go towards the ANN index. And we're extremely performant at scale there.
Awesome. That's great. I'm seeing a fair amount of questions about, the gallery that Pranav showed earlier in the demo. We put the link to his spaces, to his notebook in the chat, but I will also put that into the chat in a minute. And also rest assured, everyone in this webinar is going to get a automatic recording of the session and also a link to this stuff. So you will also get it afterwards in an email. Pranav or Yaroslav, do you see any questions in the chat or anything that you've already answered that you'd like to get to? Or I'm happy to just jump to the next one on my side if you want.
Yeah, I saw one on performance analysis with other vector databases. We'll cover that on Monday. Like I said, we are 5x I would not say 5x, but multitudes faster than PG vector and any other index on a regular database, and we're almost comparable to the upper echelon of vector databases, and that's the Zillises and the Milvises of the world. So extremely excited about that, and we'll cover that on Monday. I saw one on how to describe SingleStore in one sentence. SingleStore, to me, is the next generation knowledge platform on real-time data, and enterprise grade, at massive scale. And I think that's how I would knowledge platform with analytics, real-time data, massive scale. Those are the kind of key things I'd cover. Sorry, Matt. One more question I saw was about parallel processing. We're working on this. Our database is distributed, so we're scale out and we're very performant and massive scale for that. And our compute service today is single node, but we're adding GPUs and large memory units to it. We're also looking at making that a scale out architecture.
Awesome. Yaroslav, I'm going to give this one to you because I think that you've done work on it, but correct me if I'm wrong on this. I see a question from Carl. It says, this is big time RAG. Customers are going to want this. Customizing their front ends radically beyond Vercel. Are there any guides? And correct me if I'm wrong. Have you done a guide on Vercel, or am I misremembering that?
Yeah, Vercel is the one we showed today. I think it's a good question, and yeah, we want to go past just Vercel and JavaScript, and work really well with the Python community and with Streamlit and stuff like that. So excited to get feedback on what ecosystem are you using. Is it Hasura, and stuff like that? And these are quick integrations for us to add. So please give us this feedback, and tell us what you want, and I think we can go from there.
Good stuff. I also see a question, and actually there's been a half dozen questions on this. What are the best ways to utilize SingleStore for business intelligence? Do you already have some existing integrations, BI tools? Pranav, I wonder if you want to answer that, and I'll also try to grab some links that I can share with them in the chat.
Yeah. I mean, SingleStore powers real-time analytics and BI for some of the most influential people in the most influential companies, and that's the only way I'd put it. Our bread and butter is fast ingest, really fast ingest, at massive scale, and then being able to run analytics on that fast ingest on massive scale and serve it to many concurrent users. So we call this embedded analytics, or BI. And we have great connectors with the ecosystem, with Tableau, with Quick, with a couple of them that are skipping my head. But BI is a massive part of what makes SingleStore so successful. And our recipe for there is really fast ingest, and being able to run scalable concurrent queries, analytical queries on massive scale on that data that's being ingested. I'll put the link on our solutions page on real-time analytics here. I think that will cover more of the connectors we might have.
Good stuff. I also, while you were talking, I did a search, and we covered Tableau, Looker, MicroStrategy, Power BI, Sisense, Tibco, Spotfire. So there's a lot and I think we've got great documentation on all that stuff. So a lot of good connectors out there. Let's see. I'm seeing more questions about recording of the session. Yes, everyone will get that recording. Pranav or Yaroslav, you see anything unanswered that you really want to get to before we start the wrap-up process?
Carl, you asked a question on private instances. Yes, we do have a self-hosted version of SingleStore. You can get started with the Docker version. But yeah, this is a lot of our customers in those industries you mentioned are using us in that form. I'm trying to go through the questions if there's anything else.
Yeah, I think we might have time for one more question. You can also grab, I know you answered a lot during the session. If there was like one that you answered that you think that the community would like to benefit from, we can do that. Go
I think
ahead.
Sajith has asked this question like a couple times, and it's, do we store data and embeddings in the same table? Yes, it's the same table. Embeddings is just a separate, column in that table. And that makes it really easy to do semantic search as well as adding filters with a simple SQL where clause, and then also do aggregates with the semantic search. So being able to combine the different results of semantic searches together. So all of that is one table and SQL based.
All right, awesome. think I think that is a good place to wrap up and start our, get to our AirPods winner. I wonder if, Pranav, would you mind pulling up the last slide in your deck? I tried to put something there. Just because as I mentioned during the intro, on Monday, we are going to be presenting another webinar that's very, very similar-ish to this topic. It's called Using ANN for Vector Search at Speed and Scale. We'd love for you to come join us to learn how speed at scale can be achieved in Gen AI apps using these new ANN algorithms. If this sounds interesting to you, you can RSVP right now at that tiny URL that's on your screen, or the that QR code. I'll put this in the chat right now as well. And then congratulations to our winner for today, Clark Rhines, who is a VP at Charles Schwab. I always love trying to guess at what, the various companies are using this technology for. That sounds like a pretty cool use case at Charles Schwab. So congrats to Clark Rhines. Thank you for joining us. We'll get you those AirPods. If that's not you, don't give up. We're going to give out one more AirPods before the end of the day to someone who has tried out Pranav's notebook. So, we put that in the chat already. Feel free to give that a spin. We're also going to email it out along with the recording of this session, and we will be announcing one more AirPods winner for someone who has tried out that notebook before the end of today. So stay tuned for that. Thank you so much to Pranav and Yaroslav for an excellent demo. Excellent presentation. Thank you to our audience for hanging out with us today, and I hope that I will see you on Monday for our next webinar. Thanks, everyone. Bye-bye.
Thank you.